Hello everyone, welcome back to the second part of the PYQ that we were discussing for 6 term examination problems. And in the second part, we are presented with a slight increase in difficulty. Here it says the point with coefficients p plus root 2 into q, r plus root 2 into s, where p, q, r, s are rational numbers. Okay, so instead of our vanilla a comma b, we are given now p, q, r, and s. Okay, so integer will be a two rational point. Again, this is not named for rational point, just to create a bit of confusion, because we could have named it, right? What's in a name, as Shakespeare said. But it is called still a two rational point when all of PQRS will be integers. Okay, and it will be called a non-integer point if none of PQRS are integers. So again, we will eliminate the cases where either one of them is an integer, two of them is an integer, or three. Okay, it either has to be all integers or no integers. All right, then we will have to write an integer two rational point and a non-integer two rational point for x square plus y square equal to 3. Okay, so for this section on 3, we would just have to write both of integers and non-integer sets. Okay, for b and c, we just need the non-integer rational points. We don't need to deal with the integer rational points. So let's start. Now, since this question is a subpart of the last question, so therefore we will follow along with the solution that we obtained for the last section. Now, if you recollect the last section, we were dealing with cos theta plus m sine theta, right? We were dealing with that section, cos theta plus root m sine theta. If you remember, I'll just write it down. So, a part, cos theta plus m root sine theta whole square plus sine theta minus, I'm sorry, here the square root was on m, right? Root m sine theta, sine theta minus root m cos theta. We simplified this in the earlier parts and we got this to be 1 plus m, right? So when we looked into x square plus y square equal to 2 in the last video, you would have seen that we put m equal to 1. Now we can put m equal to 2. Alright, so using m equal to 2, we have cos theta plus root 2 sine theta plus sine theta minus root m, sorry, m is 2, right? Root 2 cos theta, and this will be 1 plus 2 equal to 3, right? Because m equal to 2. So we have two solutions to x and y from our question in the last part, right? We have x square plus y square equal to 3. We have a solution to this question where we have it in the format of trigonometry, right? I hope you can see I shortened the image. So x square plus y square equal to 3, we have cos theta plus root 2 sine theta and sine theta minus root 2 cos theta. Now we will need a integer rational point as well as a non-integer rational point, right? So for the integer rational points, we would try to avoid ratios in cos theta and sine theta. Now the only value at which cos theta and sine theta will give you integers are either 0 or 90, if we are just talking about 0 to 90. Alright, so why not start with 0? So take theta equal to 0. At theta equal to 0 degree, we have, so cos 0 is 1, right? So 1 plus root 2, okay, this is 1 plus root 2 into 0 whole square plus sine 0 is 0 minus root 2 into 1 whole square equal to 3, which means 1 comma minus root 2 is an integer two rational point. Now there might be a bit of confusion because there are no integers in our solution, right? Well, 1 is an integer, but minus root 2 is not an integer. Remember, when we were looking into the previous section in the last video, we looked into the vanilla a comma b coordinate system, where a and b were the values and those were the values in the coordinates. Here, the values in the coordinates are not the values of the solution. They are the coefficients. Okay, so if I explain it to you like this, p plus root 2 into q, right? So this one is in the format of 1 plus root 2 into 0 comma 0 plus root 2 into minus 1, right? This will imply p equal to 1, q equal to 0, r equal to 0, s equal to minus 1. Now all of these are integers, right? All. So if all of these are integers, then whatever point we obtain after setting all of the coefficients to be integers will be an integer two rational point. Alright, this is the tricky nature of this question and the contrast between the first section and the second section of this question. Alright, that is why I decided to make this into two separate videos. Alright, go watch the previous one if you are confused about why minus root 2 is being touted as an integer two rational point. Okay, so p equal to 1, q equal to 0, r equal to 0, s equal to minus 1, all of them are integers, so whatever point we obtain after putting those coefficients will also be our integer two rational point. Now it's quite easy to get a non-integer rational point. You just have to set the value of cos theta or sin theta to any arbitrary degree of theta and you will get your answer. Alright, so take, or you can use the values from the Pythagoras theorem example that we did in the last section. Alright, so I'm not going back to the last section, so I'll just take theta equal to 30 degree. Alright, then we have cos 30 is root 3 by 2 plus root 2 into sin 30 is half, and our next point would be sin 30 is half again minus root 2 into root 3 by 2 as a non-integer two rational point. Right, so simplifying, so this will be root 2 plus root 3 by 2, and this will be 1 minus root 6 by 2. Alright, this is our non-integer two rational point. If you add the squares of this, it will add up to 3. Alright, now I hope you understand how the addition will work here, because root 2 square and root 3 square, they will give you your answers. Add 4 plus 3 7, and then 1 minus 6 cancellations will occur and you will get the value upon division. Alright, don't worry, you will get the correct value because we did not make any changes, right? We just put the value of theta. Okay, second part. For the second part, we have obtain a non-integer two rational point to the circle. Now they have changed the circle to be x square plus y square equal to 11, and we do not need an integer value. We can just directly go into the non-integer values. Alright, the marking here is not correct, so this will be part 2 subpart A. Okay, and this is now subpart B. Right, okay, obtain a non-integer two rational points. So again, for this particular problem, when we are dealing with x square plus y square equal to 11, we will modify our trigonometric equation by a bit. So we will write, consider c cos theta plus d root m sin theta whole square plus sin theta, I'm sorry, I'll attach the c to the sin theta now, c sin theta minus d root m cos theta whole square. Now we are doing this because 1 plus m will not work here, right? For 3 it worked because I could take 1 plus root 2 whole square. For 2 it worked because I could take 1 plus 1, right? Instead of m I could have put 1 plus 1 or 1 plus 2, but I cannot put m equal to 10 here, right? Because that would not be following the root 2 method as described here, right? P, Q, R and S have to be coefficients of root 2. That is why I cannot put m equal to 10, because then the square root becomes root 10, right? If the square root becomes root 10, I would have to divide it by root 5 to get root 2, and q would never be an integer. Alright, so for this I would just change my trigonometry expression by a bit, and again if I simplify this, instead of 1 plus m, I would get c square plus d square m. Okay, we would not get 1 plus m because the 1 comes from the coefficient of cos square theta plus sin square theta once, and then the other will be from the coefficient of cos square theta plus sin square theta again. If you are unable to understand this step, I would suggest you to go back to the last video where we solved cos theta plus root m sin theta. There you would see we had two brackets full of cos theta and sin theta square, and cos square theta and sin square theta square. In the first of them the coefficient was 1, in the second one the coefficient was m. Here for the first one the coefficient will be c square, and for the next one the coefficient will be d square. Okay, you can just, even if you do not go back to the last video, you can just simplify it and check. Alright, I will assume that you will do this step yourself. If not, please mention it in the comment section. In the next video when we go through all of the comments, I'll take it up. Alright, so c cos theta, this will give you c square plus d square m. Now I would need c and d to, of course I'll need c as something that I'll need m as 2, right? Then I'll need c and d to adjust in a way so that I get 11. Okay, now here is something that you would have to rely on by intuition, because we would need m equal to 2. We need m equal to 2. Therefore I have 11 equal to c square plus 2d square. Now here you can just check for which values of c and d would you get 11. If you do a bit of trial and error, you will see that at c equal to 1 and d equal to 3, nope, at c equal to 3 and d equal to 1, we have 3 square 9 plus 2 into 1 square equal to 11, which is what we want, right? So we can just write, therefore c equal to 3 and d equal to 1 is a solution. Okay, once we have this, then we can write 3 cos theta plus root 2, m is 2 anyway, right? Root 2 sin theta whole square. We will put the values, right? These values into this equation. We will have plus c sin theta, so 3 sin theta minus root 2 cos theta whole square equal to 3 square plus 1 into 2, which is 11. Alright, now again take the value of theta to be something that will not give you integers, and you will get a non-integer solution. Even if they asked you an integer solution at this point, you could have placed theta equal to 0 and you would have gotten your integer 2-point solution. Okay, but here they don't want it. They just want you to give a non-integer 2 rational point solution. So take theta equal to, I can take 45 here, right? That will not be an issue. Let us take something different. So 3 into 1 by root 2 plus root 2 into 1 by root 2 whole square plus 3 into 1 by root 2 minus root 2 into 1 by root 2 whole square equal to 11, which implies 3 by root 2 plus 1 comma 3 by root 2 minus 1 is a non-integer 2-point solution, right? Non-integer 2 rational point. Because you see, to get this 1, I would have to set my q and my s as 1 by root 2. Okay, so in no way will I get a rational number there. Alright, and p, q, r and s, 4 points, right? So p is 3 by root 2, q is 1 by root 2, r is, I hope you can do this comparison yourself. So this is p plus root 2q comparing. This is just showing you that this solution works. Okay, r plus root 2 s. This will give us p equal to 3 by root 2, q equal to 1 by root 2, r equal to 3 by root 2, and s equal to minus 1 by root 2. None of these are integers, right? So therefore we have a non-integer two rational point, right? Just as we wanted. The next one, option C, this one does not relate to a circle, right? If this one does not relate to a circle, then we cannot use the cos theta and sin theta case. We can use it, although it will be a bit more complicated. Instead of cos theta and sin theta, we would be using sec theta and tan theta, because it's minus here. Cos theta and sin theta are used when we have the plus case, right? This x square plus y square. Here it's x square minus y square. So instead of that, we will be using the algebraic form. So p plus root 2q, if we want that to be our solution, right, then how would we go forward? So if p plus root 2q comma r plus root 2s lies on x square, what was the equation? X square minus y square equal to 7, right? Then I can just put the values and do a bit of algebra. So I'll get p plus root 2q whole square minus r plus root 2s whole square equal to 7, right? If I simplify this, I'll get p square plus 2q square, alright, just as we are supposed to get from the formula. So p square plus 2q square minus r square minus 2s square, and then I'd get plus 2 root 2, right? Because 2 into root 2 into pq minus rs equal to 7, right? So see, here we have a portion that is always positive, square part, and irrational part, so as to say, because it's getting multiplied by root 2. Now only if pq minus rs is 0, we will get a rational part there, but we have a rational number on the right hand side, so that means pq minus rs has to be 0. I hope you understood this logic. P square, q square, r square, s square, this part is always positive, and this part, even if we have square roots here, it will turn out to be integers, okay, or rational numbers. But the right side of this, underlined in green, by right side I do not mean the right hand side of the equals to sign, the portion that is underlined in green the second time, that portion has a root 2 associated with it. So by hook or by crook, we need that root 2 to go away. Okay, now p, q and rs are all integers, right? That was given in the question, are all rational numbers. Okay, they are not given as integers, but they are rational numbers. So if they are rational numbers, there is no way I cannot multiply a rational number with root 2 and get back a rational number. So conclusion, p square plus 2q square minus r square minus 2s square, this portion will be equal to 7, and pq minus rs have to be 0, right? If pq minus rs is 0, what can I say? I can say pq equal to rs, right? If I say pq equal to rs, right, pq equal to rs, I can just write it in the ratio form, right? P by s equal to r by q, p by s equal to r by q, which means I can write, if I take the ratio constant to be equal, I can write p equal to ks and r equal to kq. Why? Because I just assumed it to be k. Okay, I can do that thing with ratio constants. So p equal to ks, r equal to r, k, r equal to kq, and now we put this entire thing within that first equation, which we have equated to 7. Alright, now once we do that, what do we get? You keep putting the values. So if you put the values, we will get k square minus 2, you can factorize it, into s square minus q square. equal to 0. You put these values, you will get this answer. I'm sorry, this will be equal to 7, right? 7 was on the right hand side. Now once you have this, if k is equal to 3, then this section will become 7 itself, right? So I just need one set of values. Because p, q, r and s are rational numbers, I can select any one value among them just to get a non-integer solution. We don't have to solve it generally, right? A general solution will not be possible anyway because we have 4 variables and one equation. Okay, we just need one particular value. So just set k equal to 3, then you get 3 square minus 2 into s square minus q square equal to 7. So that would give you 9 minus 2, 7. So s square minus q square would be equal to 1. Okay, now this means that s plus q into s minus q equal to 1, right? S plus q into s minus q equal to 1. Again, this would mean that we can just use one particular solution where these are rationals. So I can take s plus q equal to 2 and s minus q equal to half, right? So if you do that, then you will get one solution, and you can also interchange it, right? You can take s plus q equal to half and s minus q equal to 2, whichever way you want. We just need one solution. I'm not looking into a particular solution. I just need any solution so as to obtain one required point, right? So I'll choose whatever values I want. You can choose whatever values you want. You can take s plus q equal to 3 and s minus q equal to 1 by 3. Your choice. Alright, this would lead me to a simultaneous equation where the solution would be s equal to 5 by 4 and q equal to 3 by 4. Okay, once you have this solution, you can just put it back and get p and q, right? You will get the value of k from here. K will be equal to, I think, 1 by 4, and then you will get p and r as well. So therefore p will be 15 by 4 and r will be equal to, k is already equal to 3, right? So r will be equal to, okay, we already assumed k equal to 3, so just take s will be equal to 5 by 2, p equal to ks, right? So k is equal to 3 here, k is equal to 3 here. This is much more easier. So r will be equal to 9 by 4, right? So you have a set of p, q, r and s that are rational and they're not integers, right? So if you put the values in, what would you get? In C, we have the point as, just a minute, I just write it as solve for values. So here you can, I'll give you options 3, 4, 5, anything, and you can have here 1 by 3, 1 by 4, anything. Alright, so for s plus q equal to 2, points are, what points would we get here? I'm writing them here, okay? The points would be s equal to 5 by 4. Okay, I'll write them one by one. S is equal to 5 by 4, and then I would have, I wrote it down earlier, I removed it for space. So q would be equal to 3 by 4, and k is taken as 3, right? So s would be equal to 15 by 4, and I'm sorry, p is equal to 15 by 4, and r would be equal to 9 by 4. So our points would be p plus root 2q, right? So 15 by 4 plus root 2 into 3 by 4. I can write 3 root 2 by 4, right? So 15 plus 3 root 2 by 4, comma, r, which is 9, plus s, 5 root 2 by 4. Now this is only one point, and they only want one. right? As I told you, I can keep k equal to 3 as a constant if I want. Okay, I did this because I want 1 on the other side. Even if you do not have 1 on the other side, you can proceed anyway, because you would just have to take s plus q and s minus q in a way that the product turns out to be whatever you have on the right hand side. Alright, now if I took s plus q equal to 3, you would have another set of solutions at 4, at minus 1, at minus 2, whatever you want. Even if you can take s plus q equal to 1, but then one of the terms will become 0. Alright, so be aware of it. Whatever terms you take, you will get different solutions. We do not have to obtain any particular solution, because the problem asks us to find one solution only. Okay, so any particular solution will work. Obtain a non-integer, so this basically means obtain any. Okay, now again, the question was quite easy. It was easy to follow along the instructions that were given in the question, but some bit of calculations were required, especially in the third part. All right, now again, this is obvious, because if it is a chain of questions, it will increase in the range of difficulty as we move towards the further ones. Okay, so if you have any questions, please put them down in the comment section. We will look into it. And before you watch this video, make sure to watch the first part of this particular question, where we have discussed the fundamentals that we are using in the second part. Okay, if I did this together, it will be quite a long video, and most of us do not have the patience to watch long videos, so I separated into two parts. Okay, I'll see you for the next PYQ. Till then, take care.